Hi, my name is Shehroz Ahmed, and in this video I'm gonna discuss the topic of calculus 1, that is derivatives. So by definition, derivative, we can call the derivative as the rate of change, or we can call the derivative as finding the slope or gradient of any function. That function could be of function of velocity, function of acceleration, function of time, any function. Okay, now we can easily calculate the rate of change of any function, but the derivatives in particular, they help us to calculate the instantaneous rate of change of a function. Now let's suppose we have a function whose graph is given as this one, and we want to find out the rate of change of this graph. So what we do is we'll take 2 points. This is point A and this is point B. We'll join them by a line, and then we will find out the rise of the function. Like this height, let's suppose this height is 5, this length is 6. So the rate of change from A to B will be equal to 5/6. But in this one, as we can see that this is a curve, and over here we have a straight line. So this might not give us the exact rate of change of the function at any like this gives us the rate of change between 2 points. But if we have to find out the rate of change at any time instant, then we have to find out the instantaneous rate of change. And for the instantaneous rate of change, we use the concept of derivatives. Okay, so let's suppose we have to find out the rate of change at this point C. So this is C over here. So what we do is we will draw the tangent at point C, and then we'll find out the gradient of this tangent. The gradient of this tangent gives us the instantaneous rate of change at this particular point. And in order to do it directly, we will just take the derivative of this curve. Let's suppose the function f of x is represented by this curve. We will just take the derivative of f of x and insert the value of x equals to c, and we will get the instantaneous rate of change at point C. So this is the concept of derivative, and this is why we use the derivatives. Now in the next thing, we have to discuss the notations of the derivatives, like how we can represent the derivative. What are the symbols for the derivatives? So for this one, we have to discuss the 3 notations. Alright, so here's the first notation to represent the derivative. So let's suppose we have a function of y. Let's suppose y is equal to 2x plus 5. This is the function. If you have to represent the derivative of y, we'll represent it with either dy by dx or f dash of x or y dash. This notation is called the Leibniz notation, and this notation is the Lagrange notation. These are the mathematicians whose name I'm writing over here, Lagrange notation, and this notation is the Newton's notation. So we represent the derivatives by these notations: dy by dx, f dash of x, and y dash. Okay, now let's write down the formula for finding out the derivative by the help of the first principle. So I'm just going to write down the formula with which we can find out the derivative with the help of the first principle. Okay, so let me just erase it. Okay, so derivative by the first principle. So over here we have the graph between a function f of x and the values of x. Over here, this value is x, and this value, okay, this is the one point whose x coordinate is x and whose y coordinate will be, let's suppose it's f of x. And here's another point, its x coordinate is x plus h, and y coordinate will be represented by f of x plus h. Okay, so this h is basically, it's so small that the value of h, that h approaches to 0. You can consider h as 0.0000 infinite times 0, 1. Okay, so the distance between these 2 points is infinitely small. So we have to take the instantaneous rate of change between these 2 points. So for this purpose, as I've just told you, the derivative is just finding out the slope or the gradient of the function. So the formula for the slope or gradient is equal to y2 minus y1 over x2 minus x1. So by this formula, I'll show you the formula for finding out the derivative by the first principle. So we can represent slope by the Lagrange notation, that is f dash of x equals to, now y2 minus y1, this is the y coordinate of the second point, this is the y coordinate of the first point. So y coordinate of the second point is f of x plus h, minus y coordinate of the first point is f of x, I'll write it here, whole divided by, this is the second point and this is the first point. This x coordinate of the second point, this is x2, so x2 will be x plus h and x1 is only x, so it will become equal to f of x plus h minus f of x whole divided by h. This x and minus x will get cancelled. Now this h is so small that it approaches to 0, so I'll put the limit of h approaches to 0. So here is the formula for the first principle in order to find out the derivative of any function. Okay, now we will, in the next subtopic, we will discuss the function, how we can say that a function is differentiable or not differentiable, or in other words, we will discuss the conditions where a function is not differentiable. So the question is, when does a function not differentiable? So the function is not differentiable whenever there is a discontinuity in the function, or there is a sharp turn, in the function. So if these two conditions exist in a function, then such a function is not differentiable. So by discontinuity, I mean if we have a graph like this, here's the graph. So as you can see, at this point, let's suppose this is any point, let's suppose it's x equals to 2. So at this point we have a discontinuity in the function. The limit approaching from the left side and the limit approaching from the right side is not same, so there's a discontinuity in the graph, so this function cannot be differentiable. For the sharp turn, let's suppose our function is like this. You can consider this as the function of the absolute function. It's the graph of the absolute function. So in this one, you can see a sharp turn at this point. So whenever there's a sharp turn at a point, then in that case the function is also not differentiable. So these are the two conditions where a function is not differentiable. So if we have to write down the condition for the differentiable function in the form of an equation or in the form of a formula, so I'll just write down the formula over here. But first of all, I want to explain you. Let's suppose we have a function like this. There's a function, but there's one point on the function. Let's suppose this point is 3. At point 3, this function is not defined. But if we approach the function from the left side or from the right side, we get the same number. So for this function, the limit exists, but the limit exists for this function, so this can be differentiable. So it's a continuous function. Okay, so the condition for the function to be differentiable can be written like this. Limit x approaches to a constant from the left side, f of x minus f of c divided by x minus c should be equal to the limit of x approaches to a constant from the right side, c plus means from the right side, f of x minus f of c divided by x minus c. If this condition holds, then we can call that the function is differentiable, otherwise the function is not differentiable. Okay, we will do some practice questions related to this condition, but now we have to discuss some rules, some of the rules of taking the derivatives. So let's discuss the rules of derivative. So the rules of derivatives, starting from the constant. If you have a function y equals to 2, so the derivative of this function will be equal to 0. The derivative of a constant function is 0. The next rule is the power rule. So in the power rule, let's suppose we have a function y equals to x cube. It will become equal to dy by dx equals to 3x to the power of 3 minus 1. This 3 will come over here and we'll subtract 1 from the exponent, so it will become 2x squared. So the rule is like this: y equals to x to the power of n, so dy by dx will become equal to nx to the power of n minus 1. That's the power rule. But if we have a function, let's suppose it's like y equals to f of x, it's a function of x, so dy by dx will become equal to, I'll just write f of x to the power of n, so it's like n f of x to the power of n minus 1 times d by dx of this function f of x. So this is the power rule. Now the next one that we have to discuss is the product rule. Product rule. So let's suppose we have two functions u and v. These are the functions of x. Now these two functions are being multiplied with each other and we have to find out the derivative of these two functions. So the derivative of these two functions with respect to x will be equal to u dash v plus v dash u, which means the derivative of the first function times the second function plus the derivative of the second function times the first function. So this rule is called the product rule. Similarly, we will see what will happen when the functions are being divided. So when the functions are being divided, we use the rule that is called the quotient rule. So quotient rule when the functions are being divided. So let's suppose there are two functions in terms of u and v. So these two are the functions of x, u over v. They are being divided and we have to find their derivative. So d by dx of u over v, that will be equal to v square in the denominator, and then u prime v minus v prime u. V prime or u prime means the derivative of u and the derivative of v. So this is the rule that we will apply when the functions are being divided, and this rule is called the quotient rule. Okay, now the next one we have to see what are the derivatives of sine, cosine and tan. So d by dx of sine x will be equal to cos x, and if it's like d by dx of sine of f of x could be any function. Let's suppose f of x could be x plus x squared plus x plus 3, it could be anything. So it will be like equal to cos f of x times d by dx of f of x. Now next one is the derivative of cos x will be equal to negative sine x, or if it has been written in the form of function, then it will be like negative sine f of x times d by dx of f of x. So this is for the sine and cosine. Now we will see the derivative of tan x. So d by dx of tan x will be equal to secant square x, and if it has been given in the if x is in the form of a function, so tan f of x, that will be equal to secant square f of x times d by dx of f of x. Now if there is x, then we do not need to write this part, like it applies on all the formulas that I've told you. If we have a function of x, let's suppose it's x squared plus x, then we must have to write this part, otherwise our answer will be incorrect. Okay, now the next one, the derivative of the exponent function and the derivative of the logarithmic function. So if we have an exponent function, let's suppose e to the power of x, so the derivative of e to the power of x will remain as it is, e to the power of x. But if we have d by dx of e to the power of f of x, then it will become e to the power of f of x times d by dx of f of x. So this will be the rule for the exponent function. Now the next one is the logarithmic function. So if you have to find out the derivative of the logarithmic function, so let's suppose it's ln x, so the d by dx of ln x will be equal to 1 over x, or if you write d by dx of ln f of x, it will become 1 over f of x times d by dx of f of x. So this is how we can write different rules of derivatives. Now let's move on to some practice questions, and let's see how we can use these concepts of derivatives on our questions. Alright, so here we have a question. It says find the equation of the line tangent to the graph f of x equals to x square at x equals to 3. Okay, so this is the example that we are going to do. So we have to do some certain steps. So in order to find out the equation of line, we need the slope and the y-intercept, because the equation of line is in this form: y is equal to mx plus c. So our first goal is to work out the gradient, and then we'll work out the y-intercept. So in order to work out the gradient, as I've just told you, gradient is just taking the derivative. So we will take the derivative with the first principle. So in the first step, it says what's an expression for the derivative of f of x square. So f of x is equal to x square at x is equal to 3. So by the first principle, as we have seen, that f dash of x is equal to limit h approaches to 0, f of x plus h minus f of x whole divided by h. Now because our x is equal to 3, so in x we will insert 3. So it will be, and in f of x we will put x square. So our function will be and in place of f of 3 plus h, we can write limit h approaches to 0, 3 plus h means 3 plus h whole square minus x square whole divided by h. So that would be this one, option C. Alright, so let's check this option, and it's correct. Okay, so this is the expression for the derivative. Alright, now let's move on to the next one. It says evaluate the correct limit for the previous step. Alright, so basically now we have to evaluate this expression. So I'll just do the working over here. Alright, so here is my expression. So first of all, I'll expand the numerator. That will be 3 square is 9 plus 2ab, so like 2 times 3 times h, that will be equal to 6h plus h square minus 9 whole divided by h. This 9 and 9 will get cancelled, and from the numerator I'll take h as common, so it will be like 6 plus h will be left behind whole divided by h, so h will get cancelled. Now I'll put h approaches to 0, which means in place of h I'll put 0. So my answer will be equal to 6. So for this one, my correct answer will be 6. So I'll just type it over here and check. So it will be 6, and this is correct. Okay, now what is the point we should use for the equation of the line? That's the next question. So it says what is the point that we use for the equation of the line. So till now we have found the gradient of the line, that is equal to 6. So the gradient of the line is equal to 6. Now we have to see which point can we use. So we have been given the value of x equals to 3 and the function f of x is equal to x square. So our y coordinate will be equal to x square, so that will be equal to 9. So the point will be 3 and 9. So I'll write 3 and 9 over here and check 3 comma 9, and it's correct. Okay, now the next thing is to work out the y-intercept. So in order to work out the y-intercept, I will write my equation y equals to mx plus c. In place of m, I will insert the gradient, so it will become y equals to 6x plus c. Now in this point 3 and 6, I'll put x equals to 3 and y is equal to 9. So it will become 9 equals to 6 times 3 plus c. So it will become 9 equals to 18 plus c. So my c will become equal to 9 minus 18, that will be equal to negative 9. So my y-intercept will become equal to negative 9 and the gradient will become equal to 6. So the equation will become equal to y equals to 6x minus 9. So I'll write it over here, y equals to 6x minus 9, and check my answer. That's correct. So this is how we can use the concept of derivatives to work out the gradients, and eventually we can work out the equation of the line. So this is it for this video. I hope you got the concept. Thank you so much for watching.